let's say we use nitrogen gas plus hydrogen gas to form ammonia gas. Now it turns out when we defined the equilibrium constant, we said that those square, if we define it in terms of concentrations, then those concentrations would be those square brackets. Remember that? So if we had to define Kc for this, it would be NH3 square raised to 2, N2 square times H2. Oh, sorry, I didn't balance this. Raised to 3. That would be it. But turns out, oftentimes, you don't have concentrations to work with. When you have gases, it's pretty normal to measure the pressure of gases. Does that make sense? So when you're dealing with an equation that is pretty predominant in gaseous form, we use a different equilibrium constant called Kp, where Kp, the P stands for pressure or partial pressure, okay? So Kp would be given as the partial pressure of NH3 raised to the power of 2 over the partial pressure of N2 times the partial pressure of H2 raised to the power of 3. So then the question is, how are Kc and Kp related? You can relate Kp and Kc by writing Kp is equal to Kc times RT raised to the delta N, or change in number of moles. Okay. So R is 0.08206 liter atmosphere per mole per Kelvin. And T is the temperature in Kelvin. Okay. And so delta N is the difference in moles of products and reactants. Or you can write this as products minus reactants. R is not the rate. R is the ideal gas constant. And the value of that R is what I wrote out there. Okay. Any questions so far? Okay. So let's take a look at an example. Okay. So let's say you have this reaction, 2NO in gaseous form plus O2 gives us 2NO2. Kp for this reaction is given to you, which is 2.2 times 10 to the power 12. And the temperature is given to you is 25 degrees Celsius. Okay. The question is, what is Kc? Go ahead and think about this reaction for a little bit and see if you can apply what we just learned. So here we go. The formula is Kp is equal to Kc times RT raised to delta N. So all we have to do is figure out what are each of these values. So Kp is given to us. R is 0.08206. I'm not going to write out the units. Temperature, we need to change the temperature given to us, 25 into Kelvin. So that's going to be 298 Kelvin, right? And then delta N, we need to figure out from this equation. So delta N is the number of moles of products, total number of moles of products, minus the number of moles of reactants. So that's going to be 2 moles of products, see, the coefficient 2, minus number of moles of reactants, which is 2 and 1. So that's minus 3. So that's negative 1. So let's plug this all into this equation. So we have 2.2 times 10 to the 12 is equal to Kc times 0.08206 times 298 raised to negative 1. or Kc is equal to 2.2 times 10 to the 12 over 0.08206 times 298. Go ahead and do that and tell me what you get. 5.4 times 10 to the 13. Let's do another one for practice. I'll just keep that there just in case. Okay, so here's another one. So you're given this reaction, H2 plus I2 gives us 2HI. Kc for this is given to us as 6.2 times 10 to the power 2 at 25 degrees Celsius. And they're asking you what is Kp. Okay, so the formula is Kp is equal to Kc times RT raised to delta N. Kc is given to us, which is 6.2 times 10 to the 2 times R, which is 0.8206 times T, which is 298. Now delta N is going to be 2 minus 2, right? That's 0, right? Delta N. So what is any number raised to the power of 0? What is that equal to? 1. So therefore, Kp actually ends up being the same value as Kc.